Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. The company has purchased a policy that will compensate for the loss of revenue due to severe weather events. The policy pays $1,000 for each severe weather event in a year after the first two such events in that year. The number of severe weather events per year has a Poisson distribution with mean 1. Calculate the expected amount paid to this company in 1 year. And here's the solution. Let us write n for the number of severe weather events per year. So we know that n follows a Poisson distribution with mean 1. Let us write x for the random amount paid to this company by the insurance policy in a year. Then that's 0 for n, big N equal to 0, 1, or 2, and 1,000 times n for n greater than or equal to 3. And we are looking for the expected value of x, which is equal to, by definition, 0 times probability that n is 0 plus 0 times probability that n is 1 plus 0 times probability that n is 2 plus 1,000 times probability that n is 3 plus 2,000 times probability that n is 4 plus 3,000 times probability that n is 5, and so on. Okay, and I'm just rearranging everything in such a way so that I'll end up with the 1,000 times expected value of n, which would be 1,000 times 0 times the probability that n is 0 plus 1,000 times 1 times the probability that n is 1 plus 1,000 times 2 times the probability that n is 2, and so on. So I'm a bit far from it because I have probability that n is 3 multiplied by 1,000, not by 3,000. But so 2,000 is missing. But for the next one, it's the same. 2,000 is missing. 2,000 is multiplied by probability that n is 4, and 3,000 is multiplied by. So every single time 2,000 is missing, if we add 2,000 to each and every one of those, then we'll get from n equal to 3 the expected value of n times 1,000. And of course, if we add 2,000 times each of those properties, we have to subtract it to balance it out and separately. Keep it subtracted and try to figure it out. We also need to add 0 times probability that n is 0 times 1,000 plus 1 times probability that n is 1 times 1,000 plus 2 times probability that n is 2 times 1,000. And we add that, and then we need to subtract it to balance it out. And that's exactly what is happening in what I wrote out. And because a lot of things are multiplied by 0, they basically disappear. But what is left after we do those two steps is 2,000 times probability that n is 0 plus 1,000 times probability that n is 1 minus 2,000 times probability that n is 0 minus 2,000 probability that n is 1, and so on. That's, of course, just minus 2,000 times the sum of all probabilities, which is 1, and plus that 1,000 times e of n, which I really wanted to have. So we end up with 2,000 times probability that n is 0, which is 2,000 times e to the negative 1, plus 1,000 times probability that n is 1, which is 1,000 times e to the negative 1, minus 2,000 times 1, so minus 2,000, plus 1,000 times e of n, but e of n is 1, so that's plus 1,000. So this is really 3,000 e to the negative 1 minus 1,000. That's approximately 103.638324, and that's answer B. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.